Hi everyone, welcome to Techinitializer. Imagine you are the architect of a massive digital city. You want your system to be instant, you want it to be perfectly accurate, and you want it to never crash. But there is a law of physics in the software world that says no. In the year 2000, computer scientist Eric Brewer introduced the CAP theorem. It's a brutal rule for distributed systems. It states that when you have computers talking to each other over a network, you cannot have it all. You have to make a sacrifice. To understand the sacrifice, we must define the three pillars. First, consistency. Think of this like a group chat. If I text lunch is at 1 p.m., consistency means everyone in the group sees 1 p.m. at the exact same instant. No one sees the old message. Every read gives you the most recent write. Second is availability. This is open 24 by 7 sign. It means that whenever a user asks the system a question, the system must answer. It is not allowed to give an error or timeout. Even if the data is slightly old, the store must stay open. And third, the reality check, that is partition tolerance. Networks break, cables get cut, Wi-Fi drops. This is called a partition. Partition tolerance means your system keeps running even when the server can't talk to each other. Here is the catch. You must have partition tolerance because networks will always break. It is not a choice. So when the network breaks, the forces you to choose between the other two. You are at a crossroads. You must choose CP, consistency, or AP, availability. Let's discuss the first option, the CP system. Think of a bank. You try to withdraw money, but the ATM loses connection to the main server. The bank is terrified of giving you money you don't have, so it chooses consistency. It freezes. It says transaction denied. It sacrifices availability to ensure safety. Now let's see the option 2, the AP system. Think of Instagram or Amazon. It's Black Friday. The network is glitchy. You add an item to your cart. Amazon doesn't want to lose the sale, so they choose availability. They accept the order. It might not sync with the inventory immediately, but the system stays fast and responsive. They choose revenue over perfection. In the real world, we often use a strategy called eventual consistency. It's like updating your profile picture. Your friend in London might see the new photo instantly, while your friend in Tokyo sees the old one for a few more seconds. Eventually, they will catch up. For things like likes, comments, or DNS, this is perfectly fine. For years, people thought the CAP theorem was the whole story. But there is a massive flaw. CAP only tells you what to do when the network is broken. But what about the 99% of the time when the network is working perfectly? Do we get everything for free? No. This is where PACELC comes in. It looks like a mess of letters, but it is actually a simple if-else statement. The first part is PAC. If there is a partition, means a network failure, you must choose between availability and consistency. This is the wartime rule. When the bridge is burning, do you save the data or keep the service running? But the second part is ELC. The E stands for meaning else if the network is healthy and happy. You still have to make a sacrifice. You must choose between latency and consistency. This is the peacetime trade-off. Do you want the latency? That means speed. You answer the user instantly. Or do you want consistency? That means accuracy. You make the user wait while you double check the data across all your servers. This is the hidden cost of modern web. If you choose low latency, your website loads in 10 milliseconds. It feels instant, but you don't have time to check if the data is perfect. You might show the user an old price or an old comment. If you choose consistency, you guarantee that the data is perfect. But the user has to stare at a loading spinner while your server syncs up. You are effectively trading time for truth. The CAP theorem teaches you how to survive a crash. PACELC teaches you how to live during peace. Great architects don't choose the best database, they choose the right trade off. So, this is Tech Initializer. Thanks for watching, and please subscribe for more videos like this.